Well, here's example 11, which is number 41 on page 348. This is the exact same example we just did above in example 4. Okay, so all I did was just kind of rewrite what we already formulated for example number 4, where we said X was the amount of reservoir water in millions of gallons, Y is going to be the amount of pipeline water, and then we already formed these three inequalities. And we just double check and make sure had a second, I was like, did I make sure I did greater than or equal to right there? So if nothing else, go back up into example number 4 above and make sure we have greater than or equal to, because the book talks about how we need at least 10 million. So we need the amount coming from each part, X and Y, to be greater than or equal to 10. For some reason I was thinking, I wonder if I put greater than or equal to. But so we can have those for sure in the correct way. And like before, we're going to minimize our cost. We have $300 per million gallon coming from the reservoir and $500 per million of gallons coming from the pipeline. So we're going to start right here and actually figure out what would it take in order to minimize our costs for this city. Like before, let's start over here and let's get our intercepts. Looks like they're going to be both 10 and 10 by the time you eliminate one the X and then the Y. And then this right here is just a vertical line going from 0 to 5. This is basically, X equals 0, X equals 5, two vertical lines right there. And these are two horizontal lines, Y equals 6 and Y equals 10. So if we put these on the graph, and like we said before, we're going to be definitely graphing these in quadrant 1, because we can't talk about anything other than that when we're dealing with real world situations. Let's say we want to go by 2 again, probably. So 2, 4, 6, 8, 10. Okay, let's go in here and get some colors going on. This first one goes from 10 to 10. So it's sitting right there, going from 10 to 10. And we want to make sure we're adding two values that make this greater than or equal to 10. So obviously I want to be picking stuff larger than here. So, but still staying in quadrant 1, so it's going to be everything right in here, in order for me to sum up two numbers and make it bigger than 10. Alright, the next part, let's get these vertical lines going on in here. I've got a vertical line at 0 and then 5. So 2, 4, here's 5 coming in. So here's my vertical line. Why did it dashed? I have no idea. I was looking at the shading and I was like, oh, dashed. And then here's 0 right in here. So we're talking about all of this right here in between. Everything greater than 0 but less than 5. And that's what we're talking about right there. So let me come back with the purple and make the purple more prominent, at least in this shaded region as well, so we can kind of see where it's overlapping. All right, and then last but not least, let's go in here and add in the orange values or the red values. I'm going to go from a Y value of 6 to a Y value of 10, and these are horizontal lines. There's 10 and there's 6, and if I want to shade in between, I'm looking like right in between those two right there. Alright, so hopefully you guys can see this overlap area starting from here, going down to here, coming over to there, going up, and then coming back. So we've got quite the weird shape. Make sure we got these two dots happening here on the bottom. It's all occurring right in there. Okay, so let's find some of these corner points. Let me get some of this erased, we get ourselves some room, and then let's list off those corner points. Okay, if we want to start pretty simple, up here in this top left, this y-intercept, 2, 4, 6, 8, 10, happen when we have an x value of 0 and a y value of 10. Alright, let's go to the right, directly to the right of that. Let's look at that. It's the intersection of the orange line and the green line. So that orange line, specifically right there, is y equals 10. That green line, that vertical line, was coming from the x equals 5. Well, look right there. We don't have to worry about doing anything as far as math and substitution or doing elimination method. But it's telling you it's the intersection of when my x value is 5 and my y value is 10. That's really, really nice. Very helpful in that one. All right, let's go directly below that. Look, it's at the intersection of another red or orange line, whatever you want to call it. That one this time is y equals 6. But that vertical line is still that same green one as that green one when we get x equals 5. So together they make then that coordinate of 5, 6. All right, last but not least, we just have to go directly to the left and figure out what those two are, what's happening with the intersection between those two. Well, it looks like it's the intersection of, for sure, one of the orange lines or the red lines, and that's going to be the lower one. So y is equal to 6, and then it's intersecting with, it looks like, the purple line. And that purple line is x plus y equals 10. So if y is going to be 6, if I plug that in right there, what do you have to add to 6 to get to 10? Well, an x value of 4. So this one was much easier in finding the corner points. But it's going to be the corner point 4, 6, because together they add up to 10. Okay, so now let's go to our cost equation and see what's going to give us the minimum cost. So it's going to be 300 times your x value always, and 500 times any of the y values. So 300 times x and 500 times y. And if y'all want to just kind of write all these out, and then, you know, we can take a break and we can give our brains a rest. We've been working hard. Why don't we pull out our calculators? So when you get all these written down, pull out your calculator and plug in these values, and let's compare our values together, okay? Okay, and when I went through and I just plugged in my values, 300 times 0, so that goes away. 500 times 10, that was simple, 5,000. And I did the same thing for all the other ones. Now we want to go and actually answer our question. It says, first of all, it's going to say what's going to minimize the cost, and then what is the minimum cost. Well, the minimum cost is going to come at the lowest number we have here, so 4,200. Okay. So we're going to minimize cost, or the minimum, if I spell that correctly, minimum cost of, now remember this was $4,200 or $4,200 per 1 million gallon, or 1 million gallons of water. So remember, it was $300 per million gallon of water and $500 per million gallon. So when we're using this cost equation, it's all about per million gallon of water. So now together it's going to be $4,200 per 1 million gallons of water, and we need, let's see, we want 4 million of reservoir water, because that was X. There's an R in there, but as a reservoir water, I'll put H2O. And then we want 6 million gallons, I guess I should say, of pipeline water. Because together we wanted around about basically 10 million. We wanted, obviously, if we're going to minimize our cost, if we need at least 10 million gallons of water, we're probably going to stick to our lowest bound of water that we need. So 4 and 6 is the 10 million, but we wanted specifically, you can go 8 and 2, 7 and 3, 5 and 5. How do we break it down? Well, the minimum value, the minimum cost to this city is going to come specifically when I get 4 million provided from the reservoir and 6 million provided by the pipeline. All right, and that finishes up our last example.